Hi, welcome back to COSI 4785, 5785. Today we have a relatively short lecture in which we'll finish up everything that you need to know to do the first project in the class. So we have a couple more things to discuss about conflict resolution, and then we're good to go for project 1. So given what we did last time where we built an automaton for each line of our description file, that each line described a token class, and from each description of a regular expression we built an automaton. We can take those separate automatons and combine them in a very simple way. Here's an example. We have these three automata here, and we can make them into one simply by adding a new start state and adding E transitions to each of the automata. So this automata runs all the matching automata in parallel. The other thing we do is we annotate each accepting state with which automaton it came from so that we can tell. Given an example here, we have these three token classes, and there's some conflicts in these rules, and let's look at what they are. Suppose we have the lexeme double. We're trying to scan that. There's actually two scans we can get, or two. There's an ambiguity as to whether that should be a T double or it should be an identifier. So we'll deal with tie-breaking issues like this with a very simple technique. We'll assign priorities to each of the rules. So the class that results from the highest priority automaton, and then we'll just prioritize in an extremely simple way in which we just pick the first rule that matches in the file. So we'll have our description file, and we'll just pick the first one that matches in that file. So in this case then what would happen, it would always match T double. Remember from last time that the conflict that occurs here is not a problem because we're using the maximal munch algorithm to recognize tokens for the lexer. We have one last issue we have to consider, which is we know what to do if multiple rules match, but we don't know what to do if no rules match. So we have a simple trick for this, which is that we add a catch-all rule that matches any character and reports an error. And we put that rule at the end of the file so it has the lowest priority. So in summary, we construct an automaton for each regular expression from our description file, our lexical description file. We merge them into one automaton by adding a new start state. We scan the input keeping track of the last known match, right? That's the maximal munch technique or algorithm. And then we break ties by choosing higher precedence rules. Finally, as we just discussed, at the very end of the file we have a catch-all rule to handle errors. Okay, so now you know everything that you need to know to do project 1 in the class. There is a file on the website which you should download to begin your work on project 1. And it has a stub lexical description file in it which handles just a few cases, and then what you need to do is augment that file to handle all of the tokens for the decaf language, which is the language that we'll be writing a compiler for in this class. Okay, that's all for today. See you next time.